This is the final video in the series of debunking FlatEarth-101 Flat-Earth flyer. To be honest, this is the third video, as the remaining 7 points were thoroughly debunked in my Nathan Thompson's flyer videos. Honestly, out of all their points, this one is the laziest. Jet streams on globe Earth versus flat Earth. Which one makes more sense? Followed by 2 images. Really? Lazy much? In all seriousness, which one makes more sense? Well, to me, the globe one. But do keep in mind that I know a little bit about what jet streams are, how they are formed, and why they behave that way. What bugs me is when at times, flat earthers would use a marketer projections and at time use a 3D projection, whichever suits their narrative. Can we establish a couple of ground rules first? We're not disputing the existence of jet stream, are we? Hopefully not. Can we also agree that Earth has 4 primary jet streams, 2 polar jet streams near the North and South Pole, and 2 subtropical jet streams closer to the equator? Furthermore, can we agree that they blow from west to east and the flow shifts in north and south? So far so good. Now before I try to explain what jet streams are and why they behave the way they do, would a flat earther please care to explain how it works in their flat model? In a flat Earth, may it be geocentric or not, what causes the stream? So when I'm seeing this image, what's the force that causing that circular rings? I'll wait.
They had no answer.
Thanks, Mark. While flat earthers are trying to figure that out, I'll run through jet stream just in case you want to remind yourself. So what are jet stream? Well, they are fast-flowing, narrow, meandering air currents in the atmospheres of some planets like Earth. On Earth, the main jet streams are located near the altitude of the tropopause. This is the boundary in the Earth's atmosphere between the troposphere and the stratosphere, the troposphere being the lowest layer of Earth's atmosphere, and is also where nearly all weather conditions take place. It contains 75% of the atmosphere's mass and 99% of the total mass of water vapor and aerosols. There are 4 main jet streams, 2 in each hemisphere. These are thousands of miles long despite being only a few miles wide. Next question, why? Well, in this series, I like to keep things simple. So this is a simple explanation, and you will find much more detailed and thorough explanation on the net. Some place in the Earth is cooler than other places. Like where I live, UK, it is bloody cold. Compare that to somewhere like Spain, where it is lovely and sunny. Hey, wait a minute. They're not so far away from me, so what gives? Before we get into what gives, let's talk about what happens. Imagine the warm air rising from Spain, compared to the cooler air rising from UK. To start with, in cold air, the molecules are more closely packed, i.e. denser than warm air. Thus, colder air has a higher air pressure. So you have 2 columns of air, one hotter than other, with lower air pressure. Here is where I will admit to my ignorance. I don't know enough about weather science to know exactly what happens. From my basic understanding of science, according to entropy in thermodynamics, heat will try to move to cold. At the same time, different air pressure will try to reach equilibrium. Don't ask me, I'm just a guy on YouTube. As in essence, they are really caused by the same effect. Maybe in weather science they are considered same, I don't know. Anyway, this pressure and heat difference is what causes a pressure gradient force. In theory, the warmer air in northern hemisphere would flow from south to north. This is what causes the jet stream. And in both hemispheres, this stream flows parallel to this temperature gradient. Next, imagine the Earth. It makes sense that over land, air would be warmer thanks to us humans. So even on the same latitude or on longitude, air would be on different temperature even ignoring the sun just because of us. Oh yes, I just mentioned the sun, right? Well, as the whole stream is based on different temperature between air, during winter, the polar winter is colder and we are using more heat. Thus the temperature difference is higher compared to summertime. So we have continent as a variable, then we have seasons. On top of that, let's take Earth's spin, shall we? The Earth is spinning, and that is causing the stream to blow from west to east. In theory, this jet should encircle the Earth in a continuous line. But due to all the land masses, it's more broken up. As the gradient is more prominent near the poles, polar jet is stronger. During winter, it gets even stronger, bringing the Earth's axis tilt and orbit, resulting in the jet tending to be farther south in winter and farther north in summer in northern hemisphere. On top, Coriolis force kicks in, causing the air to move to the right of the direction of motion in northern hemisphere and to the left in southern hemisphere. All this mess creates a mid-altitude low-pressure system on the northern side of the jet stream, where the streams are more settled nearer to south. I'm talking about northern hemisphere. That leads to our beautiful, precious British weather, where it rains during winter. During summer, at times we get the low-pressure systems toward us that results in, well, you guessed it, more rain. Please someone remind me why I live here? Oh yeah, NHS and education system. Oh, I did miss one other variable. Again, entropy. The heat generated from the continent. Well, when the warm air moves farther north than normal, or cold polar air moves farther south, well, technically is the warm air that shrunk. Either way, this causes the jet stream to, in a sense, buckle, driving depressions towards different region. This is as far as I can reasonably explain with my knowledge. Give me a break, I'm not a flat earther. Check Dunning-Kruger effect to know more. In our globe model, we can at least explain jet stream, but it does get rather difficult without a spin and an orbit. Just saying. Well, that's all for this video. Thank you so much for watching. If you have enjoyed this content, well, a like and a comment won't go amiss. My next video will be a short departure from Flat Earth. If you subscribe, you will get to find out about it or any future contents like this. It would also definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.